trigonometric quadratic equations. Let's have a reminder first, just in case it's a while since you've seen or done general solution. There we are. Now, this equation, we're obviously asked to find x. So we need to get rid of 3, 2, 10 degrees, and 1. So the question is, what is the order? Well, 3 multiplying something plus 1, the 1 must go first, such as 3p plus 1, the 1 goes first. So therefore we end up with 3 sine 2x plus 10 degrees equals negative 1. Now we're going to divide by the 3. There we are. Now at that stage I remind you that this is a very selfish function. Unless you use a compound angle formula, you will not get rid of any part of the angle without getting rid of sine first. So we're going to get rid of sine first, but remember, when we get rid of sine, it is important that we find quadrants, so we set it up in the quadrants with general solution. And note that sine is negative. Therefore you're going to have third and fourth quadrants, but you're not going to enter the negative on the calculator for the key angle. So, there we are. 2x plus 10 equals 180 plus. For third quadrant, 360 minus. For fourth quadrant, k360. For the general solution, and just mention that k element of z. Only once. Now we're going to find the key angle. Remember, do not enter the negative. If you enter the negative, then the calculator will be very clever and give you a negative angle, and if you put a negative there and there, you're going to end up with a second quadrant angle, and you're going to end up with a first quadrant angle. So don't enter the negative. Straight, shift sign 0.333 equals, and we get 19,47 degrees. Simplify. Now we have two equations. 2x plus 10 degrees equals 199,47 plus k360. 2x plus 10 degrees equals 340,53 plus k360. So we're going to subtract the 10 first. Note that the 10 only subtracts from the angle, does not subtract from k360, because that is an unlike term. So there we are. Now we divide by 2. Remember, you must divide both by 2, and there is our solution. Finished. Another one. This is of the type where you do not use a calculator. Now, you may remember that this type can only use the principle that sine A equals sine B, cos A equals cos B, tan A equals tan B. You can drop the trig ratio, because it's pretty obvious that if sine A equals sine B, that A equals B. Cos A equals cos B, A equals B. Tan A equals tan B, A equals B. But this is trigonometry. And remember that there's not just one angle which has a particular trigonometric ratio. There are multitudes of them, an infinite number of them in the different quadrants. So therefore we have to say, once we've sorted this out, we have to say sine 2x equals, and two possible answers with a general solution. But first we have a problem, because this isn't sine equals sine. So first we have to convert this to sine equals sine, or cos equals cos. Doesn't matter which, you end up with the same answer. Either we can make this sine, and 90 minus x plus 10, or we can make this cos, 90 minus 2x. I'm going to go for the sine. Therefore, instead of cos x plus 10, sine 90 minus that angle. Now, we can simplify that to there, and that means that angle equals that angle. But, quadrants. So it's like setting it up again, where we'll see that as the key angle. We'll see sine 2x equaling a positive value. So there we are. first and second quadrant. First quadrant, key angle. Second quadrant, 180 minus key angle, plus K360 plus K360 K element of Z, which simplifies there. Now we have two equations. We have 2x equals 80 minus x plus K360. We also have 2x equals 100 plus x. So if we solve the first equation, minus x was moved to the left, becoming plus x, so we end up with 3x equaling 80 plus K360. X on the second equation was moved across to the left, giving you minus x, so therefore 2x minus x gives you x equals 100 plus K360. There it is in writing. Divide by 3. That stays as is. There we are. But we're not finished. We're being given a specific domain in which x must exist. So now we have to investigate values of k which will give us values. Obviously 0 will, because that and that are within the region. What about negative 1 though? Well, minus 1, 26,7 minus 120 will give us inside there. Minus 360 won't for this one. What about minus 2? Minus 240 on that? No, too far. What about 1? Yes, that plus 120 gives you 146,7 within there. This one no good for 1. So k equals negative 1, and we'll have 26,7 degrees minus 120 degrees. We'll have k equals 0, which is my straight answers. And k equals 1, we'll have the 26,7 degrees plus 120 degrees. That's the reminder. Let's get on to quadratics. There we are. Have a look at this. Remember, a quadratic equation involves squareds, the variable squared and the variable, at least, but usually with a constant. This has 3 tan squared x plus tan x, so therefore tan x is the variable. So therefore I can take out a common factor of tan x, and I'm left with 3 tan x plus 1 equals 0. Now the principle of the quadratic equation, when there are two factors multiplying together equal to 0, and we're trying to find values to make it true, it will happen if we make the one 0, which means tan x equals 0, or the other one 0, 3 tan x minus 1 equals 0. So there we are. Tan x equals 0, 3 tan x minus 1 equals 0. Solve for tan x, you get 1/3. Tan x equals 0. Well, that's 0 plus k 180, every 180 degrees. Remember that tan has a period of 180 degrees, so tan is 0 at 0, and then every 180 degrees it repeats. Tan x equals 1/3. Well, that's first or third quadrant. But of course with tan we can use just first quadrant plus k 180. There's first quadrant plus K360, third quadrant plus K360, which gives us that. And there's our solution, general solution. Of course, remember I said we can use just 180, just 180. Notice, there we are. 18,4 plus K360, 198,4 plus K360. But if you add 180 onto that, you get that. So therefore we just have the plus K180, and that's fine. There's our solution. Next one. 2 sine squared x minus sine x minus 1. Here we are. Twice we have a variable squared, we have the variable, and we have a constant. Factorize, 2 brackets. I'm not going to go into how to factorize a quadratic. That bracket can be 0, 2 sine x plus 1 giving you 0, which means sine x is negative a half, or that bracket can be 0, giving you sine x equal to 1. There we are. Sine x equals negative half. Sine is negative. Quadrants 3 and 4, 180 plus, 360 minus. Don't enter the negative on your calculator. You should recognize a half as being sine of 30 degrees, but your calculator will tell you that too. Plus K360. What about the 1? Well, consider sine is positive at 90 degrees, and then every 360 degrees thereafter. So 90 degrees and then every 360 degrees. So there is our general solution. Aha. Variable squared, different variable 1. That is not a quadratic. But in trigonometry it is, because when we see sine squared, we can convert to cos squared. There we have a look. Sine squared is 1 minus cos squared. Now if I simplify that, there we are. And it's a quadratic equation. Common factor of cos x. Cos x must be 0, or cos x must be 1. For cos x to be 0, 90 plus k180. Think of the graph. And cos x equals 1 is k360 degrees. Always have a look to see if that isn't included there, but it's not. If this is k180, then k360 would be unnecessary. But 90 plus k180 never gets to k360, so we need both. Here we are, 3 examples. Pause and try them yourself. The answers follow. Let's look at the first. I brought the 3 across to that side. Factorize. Sin x equals, or sin x minus 1 equals 0, meaning sin x is 1, or 4 sin x plus 3 equals 0, meaning sin x is negative 3/4. Sin x equals 1, 90 degrees plus k360 degrees, and sin x equals negative 3/4. Quadrant, well, sine is negative in the third and fourth, 180 plus, 360 minus. I did not enter the negative. I said sine minus 1 of 0.75 to give the key angle, plus k360, k element of z. There we are. Answer. Next one. Tan squared x minus 2 tan x minus 3 equals 0. Variable squared, variable constant. Does it factorize? If it doesn't, we can still use quadratic formula. Brackets. So tan x plus 1 equals 0, meaning tan x is negative 1. Or tan x minus 3 is 0, meaning tan is 3. There we are, negative 1, 3. Let's have a look at the negative 1. Quadrants. Well, tan negative, second and fourth. Key angle, 45 degrees. There we are. The 3, tan x equals 3, positive. Therefore, first and third quadrants, key angle 71.6. Here we are. Note, you probably wondered why I went that whole long way, because lots of people find it too difficult to use the other. They prefer to use the same system for everything. But instead of 180 minus and 360 minus, I've got 180 minus and K180 instead of K360. Have a look. 315 is 135 plus 180. So therefore, that answer is better, but this will earn you full marks, 10 out of 10, maybe not a gold star. Right. Let's have a look at this one. 1 minus sine squared x minus 4 sine x minus 1 equals 0. That looks like an answer there already, but never mind, let's work through it. Sine squared x plus 4 sine x equals 0. Take out a common factor of sine. We end up with sine x equaling 0 or negative 4. No. Remember, sine only goes between negative 1 and 1. That's the range of sine, from negative 1 to 1, so negative 4 we cannot have. Therefore, x is k180. There's the graph. Have a look. 0, and then it's 0 again at 180, and it's 0 again at 360, 540, 720, etc. So, starting at 0, every 180 degrees gives you your sine x equaling 0.